So let's talk about negative numbers. OMG, negative numbers. Of the top two things that are the cause of the most pain and frustration for students learning math that goes with them from elementary school all the way to high school and beyond is the misunderstanding and the confusion and the pain around negative numbers. The other one is fractions, okay? But negative numbers, which is introduced in the sixth grade, it's not even called negative numbers, is the cause of so much of the pain and dysfunction which comes in math, usually around seventh grade, eighth grade, ninth grade, especially ninth grade when you get to algebra. So the first thing I tell, how did I discover this? A few years ago, I was a family member who was helping my nephew's daughter. She's 14 years old and struggling with math, and she had a perfect handwriting, worked very diligently, worked really hard, and was still having trouble. I was told having terrible trouble in math. So I looked at her algebra test. It was a test on quadratic equations, and she got the problem wrong, despite working really, really carefully. And the teacher looked at it and assumed that the mistake was she got the sign wrong. So the teacher, which is very understandable, very common. I mean, you get one sign wrong, you get one negative instead of a positive, and the whole problem comes out wrong. And so the teacher pointed out that she must have gotten the sign wrong. And so I looked at this and I asked the girl, I said, what's 2 minus 3? And she says 1. I said, no, what's 2 minus 3? And she says 1. I said, well, what about 3 minus 2? And she says 1. I said, well, what's 2 minus 3? And she says 1. And at that point I realized, oh my, she doesn't understand. She doesn't know what a negative number is. It's not that she confused the sign. She doesn't know what a negative number is in the first place. So negative numbers, again, started actually the first time, the very first time that I noticed that negative numbers is a challenge is my own son. Is when they called him dyscalculia. They said he had dyscalculia, right? Dyslexia, and go along with dyslexia comes dyscalculia because there's this myth that dyslexia is reversing letters, and so when I said when I said what's 2 minus 3, he would say 3 minus 2. Well, no, it turns out that's not dyslexia. It's not dyscalculia. All of my so many students, when I show them this, I show them 4 minus 8. Most students, all the way to high school, 13, 14, 15, 16 years old, will say 8 minus 4. Okay, why? Because we've been drilled in our heads since we're little kids that subtraction is a bigger number minus a smaller number. Okay, it's constantly also when I show a student 4 divided by 8, they will automatically say 2 because they see 8 divided by 4. And I have to scream. I stop them and say, no, no, no. It's not 8 divided by 4. It's 4 divided by 8. But still, over and over again. And they'll say, and the reason is because the stuff it's not, I explained to the kids, it's not your fault. We were drilled, all of us were drilled since we're little kids, that subtraction is a bigger number minus a smaller number. With division, we were drilled that division is 8 divided by 4. And so our brains, when presented with 4 divided by 8, which is not at all the same as 8 divided by 4, our brains automatically say does not compute and literally reverse it. It's not dyslexia. It's not dyscalculia. Okay? It's not their fault. They were trained to think that way. And then when we get to 6th grade, 5th grade, 6th grade, all of a sudden it's okay now. Well, now, in fact, 4 divided by 8 is a half and it's a fraction and all the trouble. So right now we're talking about negative numbers. There are two major things that are behind all the dysfunction. One of those is negative numbers. The other one is fractions. So the first thing I tell students, and I discovered this again with high school, with a 14-year-old high school girl who was, and again I say, when there are kids, who by that age are traumatized and don't want to do math. They decided they hate math. When I encountered a 14-year-old who was working hard, it was not, She was doing all the work, doing the homework, working hard on the test, studying in the test, writing the problems perfectly with perfect handwriting. You could see how much effort, and still getting everything wrong, and still trying, and then realizing the teacher thought this. The crazy thing is that the teachers, because they have so many kids in the class, they can't identify what the underlying problem is. So the teacher assumed that because she got this quadratic equation wrong, assumed that it was that she missed a sign, which is a common mistake. So that the teachers don't have are assuming the teacher assumed, for good reason, that, oh, you messed up the sign. And so often kids that know the math very well will make a mistake in the sign, which is, but again, it's wrong. And they oh, but I just missed the sign. So you, instead of getting a 95, you got a 75 because you made some careless mistake. But that's a different problem. But here the problem talking about here is not understanding what negative numbers are. And the first thing I tell all students, whether they're 10 years old or 20 years old, and I've got to do this with all of them, is the reason that negative numbers don't make sense is because, drum roll, they don't exist. And the truth is, all of math was invented by mathematicians to solve problems. But the mathematicians don't care about the real world. The problem starts with, we're raised as kids in arithmetic that math is there to represent the real world. And it does. It's a model of the real world. And we're told you have to have math. Yes, you have to be able to add 2 and 3. But the truth is you don't. If you have 3 marbles and somebody gives you 2 more marbles, you can count and say, I've got 5 marbles. But still, we're taught that makes sense. We're taught that math maps to the real world, and that makes sense until the first major abstract concept is negative numbers, which is introduced in the 6th grade. After fractions. Fractions is hard enough, but they skip I'll talk about why fractions are easier and harder, but let's talk about negative numbers. Negative numbers is the first real abstract concept that does not map to the real world. Even a fraction maps to the real world. I got only 2 out of 3, so I got 2/3. Okay. But a negative number, what is a negative number? So you ask, so until 6th grade, basically, what does subtraction mean? I've got 5 marbles and gave you 3 marbles. How many marbles do you have left? 2. This is what we do in all the way 1st, 2nd, 3rd, 4th, 5th grade. You've got 5 things and you gave away 3 things. You got 2 left. You have 4 things, gave away 1. You got 3 left. Okay, and all of a sudden we say, well, what if you've got 3 things and give away 5? And the correct response to that, now, when a kid says, oh, -2, I say, but that's good and bad. I say, on the one hand, that's good. On the one hand, that's good because they know what a negative number is. On the other hand, I say, really, the correct answer to that is you can't. Right? It's not possible if I have 3 marbles and give you 5, how many marbles do I have left? No, I have none. I can't. If I have 3 marbles, I can't give you 5 marbles. Can't do it. So what does it mean? So, but what mathematicians, what would mathematicians do? Math invented to say, listen, I don't care about the real world. I know that if I have 3 marbles, I can't give you 5, but we're going to make believe you can. And we'll call it a negative number. And it's useful. Okay, let's start with the bank account. Okay, so what does it mean that I have -$2? Can't have -$2. What it means is I owe the bank $2. But the bank, mathematicians invented a concept that says, you know what, we'll make believe that it does exist. And why? Because it's useful. It's easier to say you have -$2 than it is to say, well, you owe me money. You owe me. It's easier to say I had 3 marbles, gave you 5, and I've got -2 marbles. It's easier to say -2 than it is to say, it's more convenient. There are things you can do with this than it is to say, than than it is to say you've got -2, than it is to say that IOU. So therefore, the negative number is a useful thing. So, but I remember, a couple of years ago, a year ago, a 12-year-old kid who I showed classic 5 minus a -2. And I don't remember what he said, whether he said the answer was 3, maybe he said the answer was 3, maybe he said the answer was 5. But the answer, of course, 5 negative minus and -2 is 7. And the kid correctly said, but that makes no sense. And I said, you're right. You're right. It makes no sense. Okay. Because we invented this. Okay. So the same kid plays a video game. And on the video game, you can do all kinds of things. You can jump, you can fly. That doesn't make sense, but it's still fun. So what I explained to them is there are things that don't exist, that don't make sense, but are still useful. And a video game is a perfect example of that. And then I explained to kids, about math in general. Why is that? Why is math difficult? The truth is, true mathematicians, do not care about the real world. Mathematicians have invented something called there is something called an imaginary number. Okay, not only does negative number not exist. When you get to algebra 2, you learn about imaginary numbers. Okay, which means the way the world works is a mathematician doesn't care about the real world. He doesn't care if there's a usefulness to this concept that he's contemplating. And what happens is the applied scientist, the physicist, the chemist, in the case of probability, the chevalier, the governor who was trying to make a game and didn't understand why he was losing money, and went to Pascal and said to figure this out. Okay, the applied scientist, comes to the mathematician and says, hey, I got this problem. What do you have in your bag of tricks that can help me solve this problem? But the mathematician by the core does not care. And this is one of the reasons that math is so painful to kids, because they give you problems to solve that you don't care about. Okay, I still remember being drilled in 3rd grade. I remember it clearly. I remember we had a substitute teacher. I still remember her name, Mrs. Bach. Okay, this is 60 years ago. So this is like almost 60 years ago. So, and in order to keep us quiet and to manage the classroom, when she was substitute, she would just have the entire class. She gave us an entire sheet of 3 multi-digit addition problems. I still remember, and the drudgery of doing this. I remember doing hours and hours of just adding numbers, and it's brain dead work, and it means nothing. Why are we doing this? So yes, of course, we're doing this because you got to learn this, because there are other things that depend on this and solving problems, but all through math. I mean, think about quadratic equations, okay? Kids or just plain algebra. The students ask me all the time, Mr. Dove, when in life will I need to know that x minus 2 equals 7, that x equal 9? When in life will I need that? Like, where in life will that happen? I said, it won't. Unless you're a math teacher, or unless you're or the parent of a math student struggling, you're not going to need to know that. You will know, but I said, no, you won't need to know that. But you will need to you will have much bigger, complex logical problems in your life. No matter what you want to do in your life, okay, maybe you'll be a rich real estate tycoon someday. You'll be buying a building. You'll be reading a contract, and everything, your fortune will depend, your success or failure will depend on some minute calculation, or grammar for that matter, okay? Or the rules of life, the rules of business, the rules of getting dressed in the morning, the rules of getting in a car, the rules of doing so many things will depend on solving problems and logic, simple things, okay, simple to complex. And so what they're doing in school by forcing you to learn math, what they're doing is teaching you to solve problems. The problem is, in order to do this, in order to get you to think about how to solve problems, they're inventing problems you don't have. Okay, so the word problem that everyone hates, is contrived problems. Okay, basically, some guy, Charlie, has 1,000 chickens, and somebody took 200 chickens. How many chickens do you have left? Well, I don't care about Charlie. I don't care about that problem. And yet we don't care about them either. But they're giving us these hypothetical problems in order to learn how to solve problems. So math is not about the math. Okay. So I got off to a tangent about the negative numbers. Let's go back to negative numbers. Okay. So once you invent the concept of a negative number, and it's an invention, it doesn't exist. It's the first thing I must drill and explain to the kids. Drum roll. And they don't do this. In sixth grade, they introduced negative numbers, and they don't call it negative numbers. Search through a curriculum, the school curriculum, and you will not find a unit or the place where they introduce this concept of negative numbers. You know what they call it? It's called integers. OMG. They don't even call it, which means they sneak it into the curriculum in sixth grade, and then they tell you this is how you do it. And in fact, I never forget when I saw a sixth grader who told me his teacher, to explain that 5 minus negative 2 equals 7, did this. Extend the minus sign and put a plus. Wow. I said, this is terrible. Right? This is basically, instead of trying to explain why this is true, and it's not easy, okay? And I agree that, and I tell my students that, yes, I will explain to you that it's necessary, but do not try to wrap your head around this. Do not try to wrap your head around why 5 minus 2 equals 7. Accept the fact that negative numbers are useful. Accept the fact that somebody invented them. So when you play the video game, okay, you don't ask. It doesn't make sense that you can fly through time, fly through the air, and do all kinds of bizarre things. You accept the fact that somebody made up this video game and made up the rules. They're okay with that. But math, we expect to make sense. We expect, because until fifth grade, the math mapped to the real world in a very real way. The only abstraction was, okay, we used the number 5 instead of saying 5 things, but they can deal with that. And then all of a sudden, especially in sixth grade, we depart from that connection. Suddenly, and we don't make it clear. So my first comment is understand it. When you're just like you're watching a movie, you're watching a sci-fi movie, playing a video game. Somebody else invented this. They decided that this is true. The game of football. Who made up the rules? The rules were made up over time. It was made up. It's made up. It's a created game. It's not a natural thing. It was made up, and therefore, whoever made up the rules, whoever invented it, made up these rules. Now, it turns out they did it for a reason. There's usefulness there. These negative numbers have use. But once they invented negative numbers, they had to invent all these rules around how to add, subtract, multiply, and divide them, how to deal with them. So it turns out that subtraction of negative numbers is actually more complicated than multiplication and division, because 5 minus 2 is 7, okay, but negative 5 plus 2 is negative 3, okay, and negative 1 plus 2 is positive 1. Which means the rules around whether the sum is positive or negative depends on the actual values. Whereas with multiplication and division, that's why I'll teach multiplication and division first. Negative 5 times a negative 3 is a positive 15. Those rules are simple. Negative times negative is always positive. Positive times a positive is always positive, and negative times a positive is negative. Don't roll your eyes, parents. If you're watching this, don't worry about this. The point I'm making is that I have to explain to students of all ages the rules of math. While it is solving a real problem, you can solve real problems with it. It is useful, okay? But the rules but it was made up. It was made up to be useful, and because it was made up, they made up the rules around it. Because, like, who says, for example, that this symbol means 5? Who invented that? Think about that. Ask the average 3-year-old how old they are, and they'll hold up 3 fingers. 3. Okay, who said that this symbol means 3? Okay, but we can deal with that. But even that's made up. The whole thing is made up. The symbols equal, plus, minus, times, divide. These symbols are all made up. for good reason. So you have to accept the fact that whoever made up those symbols for good reason also made up rules, and you're not right now in many cases you will not understand the reasons why. You will not understand why it's true. You will eventually wrap your head around that. But you have to know how to add and subtract and multiply and divide those numbers. Okay, so it turns out that adding and subtracting adding with positive and negative numbers is not as simple as we think. 5 plus a negative 8. To do 5 plus negative 8, what you really have to do is you have to do 8 minus 5, and that's 3. And then, and this is not an attempt to instruction. Do not show this to your kid and say, "Oh, this is going to learn how to do that." That I do inside my community. If you're interested, you can join my free community, and there we talk about and provide resources and homework help and real explanations of how this works. But 5 plus a negative 8 really is done by saying 8 minus 5 is 3, and then saying it's a negative 3. Whereas 5 plus a negative 2 is 5 minus 2 is also 3, but is a positive 3. Okay? When eventually you will understand and wrap your head around that, it actually does make sense. But don't be so sure. But it's not as simple as you think. We think that addition subtraction is simple. It's not as simple as you think. As a friend of mine who's a kindergarten teacher once told me, ask any kindergarten kid how much 1 and 1 is, and they'll tell you it's 11. They're not wrong. 1 plus 1 might be 2. 1 and 1 is 11. Who said so? Why? So let's leave it at that for today, and we'll talk about. I'll make a separate video in my instruction. I'll make a separate instructional video on how to add and subtract, which is not so simple. So I say to students, parents come to me and say, "Oh, my child is struggling with algebra." I say, "Really? They know addition, subtraction? Show me a kid who doesn't understand algebra, and I'll show you a kid that doesn't understand addition, subtraction, or multiplication or division." Over and over again. I see this over and over again, and they can do it up to a point. Once you go back and explain those missing things, I love the aha moments. Literally, I have the aha moments. Oh, suddenly a 14 or 15 or 16-year-old remembers, oh, that's what my 5th grade teacher was talking about. I never understood that. And they had to hide the fact they didn't understand that. I just recently did that with a 16-year-old girl in algebra, in geometry. And as they learn these things that go, it's like, oh, it's amazing to see that. That's where when that clicks, suddenly everything makes sense. And that's how I see so many students go from failing to A's in short time, is once you fill in that gap. And one analogy, for example, imagine teaching someone to drive. You teach them how to drive, put the car in gear, and press the gas pedal and the brake pedal and turn the wheel, but you didn't tell them that there's gas, or an electric vehicle that didn't tell me you have to fill up the gas. You called it the gas pedal, or you just called it the acceleration pedal, and you trained them how to push the right pedal is to go and the left pedal is to stop, and you turn the wheel to turn. And then you tell them, go drive on your own, and they drive, and they run out of gas, and the car stops, and they say, "This is stupid, driving is stupid." And it's because you didn't fill gas. You didn't tell me about the gas can. You didn't tell me how to fill up the car with gas. You didn't tell me leaded versus unleaded. And that's what we're doing. But we're trying to protect the kids by not making it overly complex, right? You want to teach them how to drive. You didn't want to bother them with the kind of gas and where you get gas and where you put the gas in, how you open the gas. You don't want to deal with that. You don't want to tell them about, where to park the car and parking tickets or rules of the road even, okay? Most teens, when they first learn to drive, are so focused on just the driving aspect, they can't deal with like directions. Like, man, I got to look at the sign, okay? I forget, it was when my son was learning to drive. He was watching the navigation panel, which had the map on it, and I said, "What are you doing?" He was literally driving, thinking that he thought it was a video game. He's looking at the screen, saying, "Oh, the arrow says go this way." I'm like, "No, you got to look out the front of the car. You got to look where you're going. You can't drive based on that screen. Okay, this is not a video game. Okay, but so simple things like this, and he's like, oh, so there's so many things we take for granted, and so we think we want to protect the kids from the details, like in subtraction. We're not going to tell them that in fact, when you say 8 minus 5, well, 8 is called the minuend, and 5 is called the subtrahend. 3 is called the difference. And oh my God, who knows those things? But it turns out we try to protect them from details they don't know. But the smartest kids realize it makes no sense. The kids that don't care as much, that simply do what they're told, they can get, and that's what really destroys the smart kids. The smart kids who know they're thinking better and who understand better and are asking better questions, see other kids who are not nearly as capable as them getting an A in math, and they're struggling, and that really destroys their ability to do math. Then they say, oh, because people don't like doing things they can't do, they're not good at. And it's always the smartest kids over and over again. It's the smartest kids that can't do math and that struggle. And once you explain to them what's going on and answer their questions, it's those kids that go from failure, from zero, all the way from zero and failure, all the way to 100. My son was one of those. I do it over and over again. The kids who hate math the most, the kids who are failing and getting a zero. My son said, Dad, listen, math is the last class of the day. I'm exhausted. It means nothing. It makes no sense. I just put my head down. He was getting a zero, absolute zero, not an F, but a zero. And one day he said, Dad, you teach me math. I said, oh my, okay, I'll teach you math. Why? What happened? I said, well, the girls in school told them, it's always the social environment, the social friends said, hey, if you don't at least learn math, you won't be allowed to come back next year and hang out with us. And that was his motivation. But what happened? He was doing algebra. Literally 2 hours, one day, 2 hours, 2.5 hours, went from zero to the next test. He got a 96. The principal, the head of school, called me in tears. Your son got the highest mark in the math test. But the revelations when so many students, as one of my students now said, she said, I realize I'm not as dumb as I thought. I want to cry. Because it's always the smartest kids who are the most astute, the most questioning, who think they can't do it. And once they realize they can, it opens up the whole world. They're entirely new people. So let's leave it alone for now. And looking forward, and we'll go forward. Tomorrow we'll do some videos, some actual detailed videos, instruction videos that actually explain some of these concepts. But this is right now for the parents that don't want to learn the math, don't need to learn the math, but need to understand how they can help their kids with math.